This should be recording now. Annotating should be enabled. Let me make sure I have my chat window in front of me. Okay. I can't help. Okay. All right, so in this problem, okay, you see your parabola as the person in blue is kind of outlining. It's in the middle, right? The arcs in between, like the two pillars of the Golden Gate Bridge, forms a parabola. So that's this part over here, okay, that I'm outlining in purple. That's your parabola. And they're telling you the middle of the parabola here is 0, 0. It's going to be useful going forward if we figured out the coordinates of these other points. Specifically, this one for the top of the tower and this one for the top of the tower. Okay, 3 points make a parabola, so these are our 3 points. Let's leave them right now as blank, comma, blank, and over here blank, comma, blank. Okay. Using the information that they gave us, you know that the towers are 500 feet high, okay? And it happens to be symmetric on both sides, so the y coordinate here is 500, and over here you have that same y coordinate, 500. Anyone have some clues on the x coordinates? Good, thank you, person in blue. How did you get negative 20, and purple, how did you get negative 2100? Don't ask. Oh, well, I'm asking. It's just factual. Yeah, so we divided some things, okay, divided by 2, and so good, Alexi. Why, like, and Melinda, why do you split like 4,200 in half? What property of the parabola do you use to get that? Symmetry, correct. As the person found out, like over here, this is your line of symmetry. Okay, maybe we'll use pink. So here, right, along your vertex, which is 0, 0, this is the line of symmetry. So everything is mirrored on both sides. So when you know the whole span is 4,200 feet, half of that is 2,100 feet. Okay, so then here to here is 2,100 feet. And from the middle going this way is also 2,100 feet. You have to be careful with the signs, as the person pointed out. This way, you're going positive, but then on the other side, on the left-hand side, you're going negative. Okay, so don't forget that minus sign. Otherwise, you have the same point twice. Now from here, right, it's going to be interesting on how you go about solving this. If you wanted to try like vertex form, right? So let me make these better notes by like using symmetry, right? From symmetry, right? Line of symmetry. And so the next part is thinking about, okay, now I want an equation. So find the formula for the parabola that approximate, right? So formula up here just means equation. And if you joined me for the previous classwork, it was using factored form, using your x-intercepts, but you'll see down here, knowing 0, 0, we just have one x-intercept, right? And that's also our y-intercept. Like, that's not going to be too helpful. And you'll see, I'll demonstrate in orange. Factored form, not helpful. Or it could be helpful, we'll see. Okay, not that helpful, I should say, not that helpful. Like, all it tells you is y equals a x minus 0, and then x minus 0 over here, right? Like, or plus 0. But the good part from this is like, okay, so that's just y equals a x squared. And then from here, you can solve for A, like we did previously. Vertex form, you'll see we end up with the same thing. Okay, vertex form could work. But that yields us the same result. Minus 0 plus 0. Right, so you know that for this parabola, it has this general equation. From here, okay, Gary, Connor, my three stooges, like let's talk. Thanks. Oh, it's Frankie. Okay, I was reading the words, my bad. So from here, you can solve for, well, I kind of want to leave it there because you had good highlights, okay? Let me clear your all drawings, okay? From here, it's like before. You can solve using a point. So that we can use like this point over here in green, okay? Let's use that point. So there's your x value, there's your y value, 500. So solve for A. Y equals 500 equals A times 2100 squared. That's a really big number. So 2100 times 2100, you get this large number. 4, 4, 1, and then 4 zeros. 1, 2, 3, 4. So A equals like 1 point something really, really small. Or 0 point something, 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 something. Do that right? Did I mix up my x and y values? No? Okay. Looks like I'm going about this right. 1, 1, 2, 3, 4. So then you get A is this large number, or very small number. So I just put it into my calculator. So your final equation is y equals 0.00113, let's say, x squared for your parabola, or part A. So I misspoke. Factored form or vertex forms help you out here. I think it's the second problem where vertex form ends up being way more useful than factored form. Okay, that's part for part 1. Okay, what does f of x represent? I guess we should fix that. F of x equals height. Okay, and then x represents distance. Oops. Distance from what's it called? It's for distance from the middle. And then what's the significance of A? So this is a little bit hard to explain. You saw me previously mention that A is like the wideness of the parabola. That's what it is here. Because if it were just x squared, you'll notice it would have gone like this. Okay, this one's ending up being way wider. That's why you see it being less than 1. The parabola grows much more slowly. This is like, in green, this is like y equals x squared, and maybe in red, if you had like y equals 10x squared, it would look like this. It becomes narrower. That's kind of the behaviors of that A value. All right? So that's part A, that equation. Down here, as we scroll down, this Morrow person wants to design lights for the Golden Gate Bridge, place some lights along the bridge so that it kept it looking elegant. Find the height of the cable halfway between the middle of the bridge to a tower, and find the height of one of the light bulbs. So in our picture, find the height of the cable halfway between the middle of the bridge. Now it's just using our equation. So middle of the bridge and the tower. So then we're interested in like let me see if I can approximate this. maybe like right here, right? What's this point? And we just want the y coordinate, so right, we want this y coordinate right there. Because that's height, right? Height means y. Okay, means y. Means y value. Or f of x. Right, so if we plug in those values, you know where x is, right? X at that point, x is half of 2100, so that's 105 is 150 feet. Okay, and it's the same over here because it's symmetric. So if you go dotted, right, that's the same value. Okay, x is 1050. So then, since we know our equation, we just plug it in. And you may be a little bit off because of rounding. I think I will be in this case. X squared, put this thing in. So y equals this large number. Let me see if I can be more precise. 500 divided by 4411234. Okay, times, follow through with order of operations, 10,050 squared. Yeah, I got 125. So let's write that out. Times this thing squared, y equals 125 feet. So 150 may be the total distance. Careful what you plug in there, unless I read something wrong. Let me double check. Find the height of the cable halfway between the middle of the bridge to a tower. No, wait. Middle's here, tower's here, halfway between the middle of the bridge and the tower. Yeah. So you might have found like, where'd you get 250? 250 is like half of this middle, right? But they didn't want the middle of the y. They said middle in this part, right? Halfway between the middle of the bridge to a tower, that's actually where the x coordinate is. That's this way, right? Here, versus like halfway here. To find the height of one of the light bulbs. So like here, your answer should be 125 feet in the air. That's part B. I could be wrong if I'm misreading it. Pretty sure this is it. No? Yeah, height. Height is y. What happening? So, like, if you mixed up, like, f of x and... Oh, that's so easy. Right, getting 250... Right, if you were thinking, like, the opposite way, you were figuring out, okay, halfway, like, for the y, what is this x coordinate? You notice that's not in the middle between the middle tower and the tower and the midpoint, or this vertex, right, line of symmetry. Yeah, so thinking about, like, that's why they asked you, like, here, what's f of x represent and what does x represent? Because you could flip the two, and then you'll solve a different version of the problem. And you notice, for me, it's really helpful to write this out, okay, and then draw the picture. Like, this is where your string of light bulbs go. Okay, that's it for today. Class, I reviewed this one problem. Tomorrow, we'll talk about the baseball problem down here, right? Is it a homer? There's a lot going on for this problem. If you did it already, that's great. Just double check your work. There's lots of parts going on, but still it's practicing parabolas. I'll post this like after 4 o'clock, so those students get a chance to work on it. You can, Raymond, if you want to just play around with breakout sections. I still can't find the equation for the first sentence. Oh, okay. Ben, yeah. We'll work through that. Uh, Ben, if you could join the 4 p.m. session, that would be great. Maybe we can start with that one. Okay. Everyone else, thanks for joining me today. If you want to join the 4 o'clock one, you can. But otherwise, it's like optional. Yeah, yeah. Ben, I got you. I'll send you some notes. Where is my OBS? All right. So I'm gonna stop sharing. This stuff will be